Alright, in this lecture we're going to be taking a look at trigonometric functions and how the chain rule applies to these. So if we have the derivative with respect to x of sine of the function u, okay, and then u is going to be at the variable x there. Basically, we do the same thing as we were doing before, so the derivative of sine is cosine. But then we're going to have to remember to multiply by the derivative of u. So we have cosine u times the derivative of u. So we can apply that same knowledge here. The derivative of the cosine of u, so notice this is an x down here and this is a u, we're going to get negative sine u times the derivative of that function u. Okay, so it's negative sine u times u prime. For tangent, so it's the derivative with respect to x of tangent of some function. So we're going to get secant squared u times the derivative of u. For the derivative with respect to x of secant u, we're going to have secant u times tangent u, and then times u prime. For the derivative with respect to x of cotangent u, it's going to be negative cosecant squared u times u prime. And for the derivative with respect to x of cosecant u, it's going to be negative cosecant u cotangent u times, you guessed it, u prime. So we really do the exact same thing we were doing, just now we're going to multiply by the derivative of that inside function. So in our first example, here we have the sine of 2x. So when we look at this, the inside function is u equals 2x, and the outside function, f of u, would just be the sine of u. So we need to find u prime, which is 2, and we need to find f prime of u, which is just going to be cosine of u. So all in all, y prime is going to be cosine u, and we're going to go ahead and substitute u back in, times u prime, which is 2, and then we're going to rewrite this by moving the constant multiple to the front. So we get 2 cosine of 2x. And there is our derivative. So let's go ahead and try letter B. So y prime. Okay, here we have cosine of a function, so the derivative is going to be negative sine of that function, x minus 1, times the derivative of x minus 1. So times the derivative of x minus 1. Okay, so all in all, the derivative of x minus 1 is just 1. So we're left with negative sine of x minus 1. Alright, for tangent of 3x, now we're going to get 3x in here, and so y prime equals, well, the derivative of tangent is secant squared, so we're going to have secant squared of 3x times the derivative of 3x, which is just 3. And so we can write 3 secant squared of 3x. Now hopefully you can see I did these all kind of in three different ways. The first, I separated out an inside function and an outside function, and I found each derivative, and then I multiplied using the chain rule. In the second one, I just set up the chain rule. So I found the derivative of the first times the derivative of the inside, and then simplified. And then in letter C, I kind of did it more in my head. So I found the derivative, and then I made sure to apply the chain rule by multiplying by the derivative of the inside function. Okay, and this would be enough for me. Unless you get confused, then you might want to try the way I did it in A or in B. All right, in this next set of examples, we're going to be looking at how parentheses can affect doing these problems with the trig functions. So if I see something like this, this is really going to be the cosine of 3x squared. Okay, and so here I can just apply the rules that we were just doing. So the derivative of cosine is negative sine. Okay, we're going to keep that inside function, and then we're going to multiply by the derivative of this. So that's going to be 6x. And then we just want to rewrite it so that our constants and our multiple out here is going to go in the front. So we get negative 6x sine of 3x squared. Okay, so when you see this, that is all, we're taking the sine of this entire thing. If we look at letter E, now we have the cosine of 3 in parentheses times x squared. Well now, the cosine of 3 is just a constant, so we can use the constant multiple rule with our power rule of x squared. So y prime in this case, remember the 2 is going to come to the front, and this is going to subtract by 1. So we get 2 cosine 3 times x to the first. And then we're going to rewrite this here as being 2x cosine of 3. For letter F, here we have the cosine of 3x squared. And the cosine always is going to get evaluated last here. So this is really going to be the cosine of 9 times x squared. So we apply the square first, and then we take the cosine. So our inside function is 9x squared. And so the derivative of cosine is negative sine of our inside function times the derivative of that inside function, which is 18x. Okay, and then we're going to move that 18x to the front, so negative 18x sine of 9x squared. Okay, so hopefully you're getting used to those parentheses. Now in letter G, when we see cosine squared x, I'm going to encourage you to rewrite this as cosine of x squared. Now you can see our chain rule is going to be, we have the inside function of cosine x, and we're going to use our general power rule here to find our derivative. So we're going to get 2 times cosine x to the first, and then times the derivative of cosine x, which is negative sine x. And we'll clean this up a little bit. We'll put the negative out in front with the 2, and then we're going to have cosine x times sine x. For letter H, we want to rewrite this as cosine of x to the half power. And so again, this is a similar situation where we're going to use the general power rule. So y prime is going to be 1/2 times cosine x to the, well, 1/2 minus 1 is negative 1/2. And then we still have times the derivative of cosine x, which is negative sine x. And when we write this, we want to move that negative to the bottom, and then we'll change it back into a square root. So we have negative sine x over 2 root cosine x. Okay, so those were just some examples on what to do with the parentheses and seeing these in different forms. And then also to apply the chain rule, sometimes you use the trig chain rule and sometimes you don't. Sometimes you just use the general power rule. In our next example, we're going to look at a repeated application of the chain rule. So we're going to end up using the chain rule in terms of our trig function as well as a general power rule. Alright, in our first example, we have f of x equals sine cubed of 4x. So let's go ahead and rewrite this using our exponent on the outside of this. So this would be the sine of 4x cubed. Now looking at this, we have a function that is cubed, and then we have another function right here. So this is almost like having f of g of h of x. So we see a function completely buried inside the g, and then that is buried inside an f. So we have three functions going on. So the way we're going to do this is just by dealing with this using the chain rule, and we'll just do this multiple times. So if we're going to look at f prime of x, let's deal with the outside function first, which is something cubed. So we're going to use our general power rule here. So we're going to get 3 times that something, and then squared. Now it's going to be times the derivative of that inside function, which is sine of 4x. Now, let's go ahead and deal with finding the derivative of sine of 4x, which we know we can do. So we'll just go down below here. So derivative of sine is cosine, and it's going to be of that 4x, and then times the derivative of that 4x. And we know the derivative of 4x is 4. So I just kind of showed each step here, and if we bring it all together now, we're going to get 3 times this. So we have 3 times sine squared 4x times, we'll bring this down, cosine 4x, and then times 4. And now we can just do the 3 times 4, which is 12. And there we have our final answer. Okay, so you can see when you have functions, multiple functions embedded here, that you just keep doing the chain rule until it all works out, until there's nothing left to find the derivative of. So you just keep going as many times as you need to. Go ahead and try all the problems on the back page and bring those to class with you, and we can discuss them there. Alright, so that has been using trigonometric functions and the chain rule. Thanks for watching, and we'll see you in class.